Before starting this next section, please refer to the answers on the last assignment regarding logarithms and exponential functions and how they're related. We're going to talk about properties of logarithms today, and this is quite lengthy and quite deep mathematically. Okay, now here's our goals today, and there's a bunch. And you look through those and you can see that we're going to be busy today with new concepts. The first concept is this. If you take a logarithm of two quantities that are multiplied, the product, that means we can split them and add them. And it's much like multiplying exponential functions. We add the exponents. Well, we add the logarithms, because remember, a logarithm's answer is an exponent. If we divide two quantities, the quotient, we subtract the logarithms. And then the third property, which is really important, if you have an exponent when you take the logarithm of something, you can take the exponent and move it out front. And that really makes a difference when you're solving equations and expressions. So here are some expressions. Now, we can expand this because it says log base 3 of 10 times z. So that would be log base 3 of 10 plus log base 3 of z. Well, that's not hard, is it? Here's the quotient rule. Log y minus log 2. Now, if you remember, cube root is 1/3 power. So this is actually then 1/3 natural log of t. So take your time, pause it, look those over. Those properties go with the examples here go with the properties. So on D here, we have multiple things going on. We have multiplication, we have division, and we have a radical sign. So the first thing we probably should do is change that square root to a fractional power. So now we have a product and a division. Well, you want to do the division split first. So we're going to take log base 2 of x to the half times y to the fourth minus log base 2 of z to the fourth. Okay, so we got our subtraction. We got our division. Now I see a product. Okay, log base 2 of x to the half plus log base 2 of y to the fourth minus log base 2 of z to the fourth. Okay, getting closer. Now you'll notice I see a bunch of exponents, so we can move those exponents to the forefront of each term, and we end up with 1/2 log base 2 of x plus 4 log base 2 of y minus 4 log base 2 of z. And to be technical, since this is multiplied, we probably should do this first, just to be safe. So there's our product in the numerator, and then our denominator was z to the fourth. That's an expansion of logarithms. Okay, now I would have you do E and F on your own and then come back and check. So go ahead and pause it and do it and see what you come up with. Okay, as I'm working this out, I see that the log base 7 of 343, I believe that is that 3 to the third, or 7 to the third? Let's see, or 7 to the fourth. Yes, it's 7 to the third. So this would be log base 7 of 7 to the third, which would mean that we could move the 3, that's a 7, out front, and then we'd have log base 7 of 7. Well, look at that, guys. That cancels. So the answer would be 1/2 log base 7 of x minus 3. Now, you wouldn't think you'd get to there from the initial, but you do. Okay, what about f? Okay, that's pretty standard, right? Well, 2 to the fourth is 16. And I can put these exponents out in front of these two. But now, log base 2 of 2 to the fourth, I can put that 4 out front. And log base 2 of 2 is 1. So it's 4 minus 4 log base 2 of y plus 3 log base 2 of z. Ah, pretty interesting. That's that expansion. Now, we're going to take the same thing and we're going to condense them into what we just did, right? So we know that minus means division. So this would be log base 5 of 8 divided by t. Okay, let's see. The negative 4 is out front of log base 6 of 2x. So that would imply then that the negative 4 is on 2x in general, right? Has to. And that's it. Oh, positive quantity. Yikes. So we need to move that into the denominator. There we go. So that would be log base 6 of 1 over 2x to the fourth. Because we got to make that exponent positive. Okay, now this one we're going to have to do some magic on. So ln of 8 squared plus ln z minus 4 to the fifth. Okay, plus means multiply. So that means we're going to have ln of 64 times z minus 4 to the fifth. Well, that wasn't bad, was it? We're just condensing now. Ooh, look at D. Okay, so just take it piece by piece. You're going to move the 1/2 up, right? And we really can't do anything with the right side. Okay, now we can also take that log, or that 2, move it, and that's all still to the 1/2 power, which remember is the square root, right? Remember, we're trying to get it to just log base 8 of something. Well, multiplication means we can just make this log base 8 of y squared times y plus 4 to the half. Sorry about that. Okay, well, 1/2 implies square root and minus means division. And there you go. So log base 8, I probably should put parentheses around all of that. There we go. Log base 8 of the square root of y squared times y to the plus 4 all over y minus 1. So this expansion is condensed to that. It's kind of fun, isn't it? Okay, now we can rewrite any logarithm. You know, the other day we talked about logs and we didn't have log, which is base 10, or ln, which is base e. We had log base 2 and 3 and 4, and I had a graph and it was log base 4, I think. But it doesn't matter. We can still change that base so we can use it on our calculator. Now, if you have a fancy TI-84 calculator, to change your base, I got to find it quick. You go to Math. I'm looking here. Is it number? Nope. Oh, it's Math A, log base. And you literally can type in the base and everything. Now, if you have a TI-83, you're not going to be able to do that. You're going to have to use what's called the change of base formula. And here's the change of base formula. So literally, oops, that should say ln. That's a typo, sorry. That should say ln base a of x. No, it shouldn't. Oh, I apologize. No. So the log base a of x is equal to the log base b of x over the log base b of a. In other words, this b is usually a 10. So another way of writing this is just log x over log a. So let's say you can't type this. Let's say it's log base 2 of 15. So how do you type that on your calculator? Well, if you have a fancy one, 84 and above, you just go to that Math A, log base. But if I have a TI-84, I'm going to type it in like this, log 15 over log 2. That's it. That's all you do. And then hit enter, and it's the correct. Now, if you wanted to graph it, you would graph log, so let's say we had an x in there, obviously, and we can graph it by changing the base. Now, I can also use the natural log. I personally use the natural log usually. So you could do ln 15 over ln of 2. And I want you right now to go ahead and type both of these in there, and you will see that you get the same answer. So change of base is really important to solve equations. Now it says, rewrite each logarithm using the change of base formula and use your calculator to find the answer to 3 decimal places. You can use log or ln. You do not have to use both. So I would encourage you to use the change of base, even though your calculator will do it for you. So this would be log 5 over log 1/4, or ln 5 over ln 1/4. And so let's see, 3 decimal places it says. So natural log of 5. Make sure you close parentheses, guys. I got negative 1.161 if we round it. The next one, log 36 over log 7.1, or natural log of 36 over natural log of 7.1. So either one will give you the same answer. 1.828 approximately. Okay, so that's using the change of base formula. Now there's a reason we change bases, and that's to solve equations. Now here's a couple properties. We already know a to the x equals a to the y if and only if x equal y. We know that. We also know the second one. We've already talked about these. We know the inverse property, that these cancel out. We've already done this. Okay. And we're going to do that then to solve equations, okay? So 3 to the x equals 243. Now, we can start guessing, okay? But there's another way to do it, and it's logarithms. And I would encourage you to do it this way because it makes it so quickly. So if I use logarithms here, because it's exponential, and I take the natural log, now again, it's 3 to the x. You do not have to use natural log. You can use log. It doesn't matter. Well, let's do the math here. Where does the x go? Well, the x goes out front, right? That's what we just learned. Now, how do you get x by itself? Oh, we divide by this number, natural log of 3. So this is our exact answer. Now, what is the answer? Well, let's see if it's exact. So type that in your calculator, and it's 5. So there is no decimal. Now, you may recognize that 3 to the 5th is 243, and that's fine. You can bypass. You don't have to do this. But to undo an exponential, you can always do the log and vice versa. Okay, now, let's say we don't have this nice, tidy answer like we had before. We have a 5 in front. So we have to get the exponential part by itself first. So that leads us to this. Do not put that in decimals yet. You get 10 to the x minus 6 equals 7/5. Now that's impossible to solve exponentially. So you have to take the logarithm or natural logarithm of both sides. Now, quick question though. Recognize the base is 10. What is base 10 in logarithms? Log, right? So if I take the log of this and the log of this, remember if you do it to one side, you have to do it to the other, correct? Well, it just so happens then that the bases, excuse me, gotta let my dog out. The bases are going to cancel out because I'm going to take x minus 6 and put it out front. And I get this. So the log of 10, guys, is 1. So I'm left with x minus 6 equals log of 7/5. Now, how do you get rid of the 6? Add it, right? 6 plus log 7/5. Now, I know some of you want to go ahead and write log 7 minus log 5, right? Because of what we did before, because division means we're going to subtract, but you don't have to. This answer is exact. Then we're going to put it in our calculator and calculate it. X would be approximately then, the approximate answer would be 6.15 if we go 2 decimals. 6.146 to be more accurate. The exact answer is right here. Okie doke. These are so fun. Okay, again, get exponential part by itself first. Subtract 10. Okay, now we do the log, right? Now you can do log or you can do natural log. It doesn't matter. So I'll probably do natural log just because that's what I use. So the x, the exponent, comes out front, remember, by our rules, which allows us to divide that out, and there is our exact answer. This is exact. Now, what's approximate? Well, it's what you put in your calculator. Natural log of 37 divided by natural log of 6. Be sure to use parentheses. 2.015, approximately, solves that equation. You would not be able to solve exponential functions like this without using your calculator, without using logarithms too. Okay, so now we got this one. Okay, what's the only way to get the exponent out front? Well, it's to take the logarithm, or the natural log. Now this time, just to be different, I'm going to take the log. Okay? And I got to take the log of 4. So now the 365t comes in front of the logarithm. And I'm afraid this decimal is too big. I really don't want to put that in my calculator because it might be too much to write. Now this is times and this is times. So how do you get t by itself? Well, how do you undo times? Well, we divide, right? So literally, t is the log base 4 divided by 365 times the log of 1 plus 0.065365. So that would be our answer. Now that's a lot of parentheses we got to navigate. So make sure when you divide, you put the entire denominator in parentheses. Log of 1 plus 0.065 divided by 365. How many parentheses do I have to close one? So time is about 21.33. In other words, if we got 6.5% interest compounded 365 days a year, and we started with $1 out front here, how long would it take us to quadruple our money at 6.5% interest? Well, it only takes us 21 years. That's pretty amazing. Okay, 3 times e to the x plus t, 2, equals 75. Well, again, you got to isolate it just because it's easier that way. All right, now how do we get the x plus 2 out front? Well, we got to take the log, right? But look at the base. It's an e. So this time you definitely want to use natural log of both sides because those cancel out because the natural log of e is 1. So we end up with x plus 2 equals natural log of 25. So the exact answer is that. Natural log of 25 minus 2. Now, you want the approximate answer? Well, type it in. We've got about 1.219. All right, now we're going the other way. Now we're going to solve logarithms. And we're probably going to have to use exponential form. So the suggestion is to make the logarithm part by itself. Okay. So, oh, wait a minute. I could have divided by 5. Yeah, let's do that. So that's 11/5, isn't it? Okay, so now I can write this as an exponential function. 10 to the 11/5 equals x minus 2. Haha. How do I get x by itself? Add 2. There's my answer. So 10 to the 11/5 plus 2. So the exact answer is this. The approximate would be 160.49. That's the approximate answer. Pretty slick, huh? Because this is times, I can divide by 5. It's much easier than having to deal with the exponent. We don't want to deal with the exponent. Okay, here's another one. Natural log of the square root of x minus 8 equals 5. Well, the first thing we need to do is clean it up. There. Now, where's the 1/2 go? Correct. Out front. Okay. Now, that's a times. How do you undo a half? Well, we can divide by a half, or we can multiply by 2 both sides, and that gets rid of it. So this would be the natural log of x minus 8 equals 10. Now, what's the base of natural log? An e. So it's e to the 10th equals x minus 8. So x would equal e to the 10th plus 8. There's your exact answer. And my approximate would be 22,034.47. So kind of fun, kind of neat. Let's see if that works. 22, that answer, I'm just going to go second answer minus 8, the square root of that, and then the natural log of that. And it's 5, exactly. Awesome. Okay, oh, now we're going to throw a subtraction sign in there. Ooh, let's see. How about we subtract 2 first? That's 8. And then what if we just divide by -6? That's -4/3, right? If we reduce it, and remember this is e, so e to the -4/3 equals x. So there's our exact answer. And in decimals, that's about 0.2636. Okay, pretty slick. Rolling along here. Now I know this is not easy peasy stuff here. So to solve for d, we are going to have to do a condensation of the logarithm, meaning that we can't have multiple logs. We need to make it one single logarithm. Well, since it's multiplication, or addition, sorry, we know that it looks like this. X times x minus 8. Well, to me, we're ready to go ahead and convert that to exponential. 3 squared equals x times x minus 8. That would be 9, right? Well, heck yeah. So now we have x squared minus 8x minus 9. So can we factor that? Yeah, we can factor that. Let's see, x minus 9, x plus 1. So x equals 9 and x equal -1. Now, you read the little bullet underneath. When a logarithmic equation has a variable with a degree greater than 1, meaning the squared term, you need to check for extraneous solutions, which means solutions that don't exist. And here's why. Because if I put -1 there and there, your calculator is going to give you an error, guys. You can't have a logarithm. You can't take the logarithm of a negative number. You can't take the log base 3 of -1. You can't take the log base 3 of -9 because there's nothing you can square to get -9. That's a real number. That's a real solution. So the only answer then is x equal 9. So you must check that. Okay, so here we go. Here's another plus. So that'd be x times x minus, oh, sorry, same problem. We already did it. Here's one for you. Ooh, minus sign. That would be division. Okay, well, both sides are natural logs. Thus, we literally can just do this and say x plus 1 over x minus 2 equals x. Now, how do we solve that? Well, we've got to multiply by the denominator, clean this sucker up. So x plus 1 equals x squared minus 2x. Set it equal to 0. So you subtract x, subtract 1, and you get x squared minus 3x minus 1, which would factor to nothing, right? Okay, so what do we have to use? The quadratic formula. Okay, so negative b would be positive 3. Negative 3 squared minus 4ac all over 2 times a. So that would be give me 3 plus or minus 9 plus 4 all over 2. 3 plus or minus radical 13 over 2. Well, there's one solution again that's not going to work. And that would be the 3 minus radical 13 over 2, because that's going to give me a negative number. So the only answer is 3 plus radical 13 over 2. We don't want many of those, do we? Feel free to pause this at any time. Okay, now we do have a lot of real-world relationships with this. How long will it take your investment to double at 6.85% interest when you invest $3,000? Compounded monthly. Okay, so let's go through the formula. This should look familiar. Okay, we want to know how long it'll take to double. That means we want 6,000 from 3,000. Monthly. And we need t. So there's our equation. Obviously, that's going to be 2. I'm thinking we probably don't want to mess with that number inside parentheses yet. What's the only way to get our 12t, the exponent? How do we get that out front? Yeah, we have to take a logarithm. So I'm going to take the log of both sides. Now, usually I use natural log. I think I told you that. But that would allow you to do this. Take that exponent, 12t, and move it down. Now again, remember that problem we had, times, we just want to get t by itself. So we could divide by 12 log 1 plus 0.0685 divided by 12. So this is a big one. So log 2 divided by parentheses 12 times log 1 plus 0.0685 divided by 12, close. I got about 10 years. So about 10.15 years it would take to double your money at 6.85% interest, compounded monthly. That's not very many years, guys. Okay, example 7. Number of trees per acre N of a species is approximated by that model right there, where x is between 5 and 40, and x is the average diameter of the trees 3 feet above the ground. Use the model to approximate the average diameter of the trees in a test plot when N is 21. Okay, well, when you see a base 10, you know it's going to be log because it's going to be nice. So 21 divided by 68, is that a nice decimal? No, it's not. So let's keep it. Keep that number. Now, we're going to have to take a logarithm to get this exponent out front. So I want to use log because log base 10 and the base 10 right there would cancel out. So you have log of 21 over 68 equals negative 0.04x. So then we can just divide out negative 0.04. So this is when you want to use log. So log of 21 divided by 68 divided by negative 0.04. On average, I got 12.76. Now what's the units? Trees per acre, feet. 12.76 feet. Gee, Merry Christmas. Those are big, huh? Did I do something wrong? I don't think so. Log of 21 divided by 68 divided by negative 0.04. Yep. Those are some big trees. Must be in the redwood forest. Okay. Demand equation for a microwave oven is that. Find the demand X for a price P of $3.50. All right, so $3.50 equals 5,000. 1 minus 4 over 4 plus e to the negative 0.002x. What are we going to use? You're right. We're going to use natural log, aren't we? Now, I'm going to start by dividing by 5,000. And that's 0.07. That leaves me with 1 minus 4 over 4 plus e to the negative 0.002x. Looks like we need to subtract 1. Wouldn't that be negative 9.3? Yep, negative 9.93. And then that would leave me with negative 4 plus 4e to the negative 0.002x. Negative signs would cancel out. Let's see. Well, we could use ratios, proportions, cross multiplication here. It's probably the easiest way. So 0.93 times 4 plus e to the negative 0.002x is going to equal 4. So that means I would divide by 0.93 and subtract 4, right? So e to the negative 0.002x equals 4 divided by 0.93 minus 4. Not even using anything yet as far as simplification goes. Well, then I can do the natural log. So those will cancel. So I have the natural log of 4 divided by 0.93 minus 4. And then I can divide by a negative 0.002, and there's x. Oh my goodness. But it works. 4 divided by 0.93 minus 4. Divided by negative 0.002. What's the price at $350? About 600. That's what I got. So let me see if I gotta make sure I did my math right here. 4 divided by 0.93 minus 4 natural log. Yep, that is correct. 600. And that is finally the last slide. I would take your time on this. The worksheet on the properties of logs is 2 pages, 32 questions. Take your time. Answers will be posted, and I'm going to have my Zoom open Friday and Monday during seminar.